Alright, so another math, easy. So we're going to discuss logarithmic functions and their properties. Look, introduction. This is really useful in all of math and calculus and whatnot. And I'll show you what I mean. Let's start if we have an equation, exponential equation like y equals f of x or a to the x. So basically, this is exponential function, and you can see my other video on it. And now let's say we want the inverse. So we want the inverse of this. And if you see my other video on what inverse are, well, basically you just switch x and y, we switch and solve for y. Solve for y. So we do that right here. We'll get basically x equals a to the y. And now, how do we solve for y? Solve for y. This is what we don't really know with our just basic knowledge of algebra and whatnot. So now what we actually have to do is define, well, basically this log, this was defined, or logarithms for, if you want a long term of it. So that's logarithms. Basically what this is saying is, if you have a function like x equals ay, then the inverse, or y, would just equal to log base a of x. So this is all it is. This is the definition. And we could actually use this in a great deal for a lot of stuff. So let's say, and also this is the inverse. If we were to graph it, you see my video on why this is true. It's actually just a reflection of the y equals x line. So what I mean is, if we were to draw here, this would just be a to the x. And you see my other video on how to graph these. This goes to infinity and it goes to 0 as negative, x is negative infinity. And if you see my other video, it's actually the reflection of this. If this is y equals x line, now log a is just going to be reflection of this. This is going to be the perfect reflection of it over here. So it's going to be like something like this. And the range and domain switch. So this is basically log ax. And basically the domain, which is all the x values, is going to switch for the range. So this is going to be up and down, and then domain, the range here is going to be the domain, which is going to be like this. So 0 to infinity, now it's 0 to infinity on the x. So this is really useful to know, and then you can just graph it really easily. It just goes like that. And now here, let's look at some properties or laws. Properties or laws of logs. This is really useful, and they'll help out a lot in a lot of fields of math. So let's go with the first one. If we have log a of, well, basically a to the x, a to the power of x, this just equals x. And I'll prove this soon. This is really useful because when you have this same base and then a to the x, all you do is move the x down. So then the proof here is basically, if we look at the definition again, which is basically that x equals ay, y equals log of ax. So if we look at that again, so we go x equals ay, and y is defined as log ax. So we could do here, in this case, ax is acting as x, so we'll have ax equals ay, and this, if you just look at it, y equals x. So that's the one proof. There it is. Let's look at number 2. Another property or law. We'll go with a to the power of log a of x. This also just equals x, and this proof is simple too. If you look at the top here, the top log ax, this just equals to y in terms of x equals ay. So if we put this one is y, then we'll be left with a equals y, a to the power of y, and this just equals to, well, x by definition. So then that just equals x. So we got that proof. Now let's look at another proof. Let's go this one. If we add logs, log a y plus log a of x, this just equals to log a y times x. I'll show you the proof here. Well, basically, this one right here, this just equals, let's call this y1. And this is y2, because we'll just have basically a to the y1 equals y, and a to the y2 equals x. So now we're just adding these two together. if we're, yeah, so we'll have, basically we'll have this. So basically log a y plus log a x equals to, well, y1 plus y2. Yeah, so now let's say we have this. Let's say we want to, we could also write something like this. We'll go write a to the, and so a to the y1 plus y2. This would equal to basically a, if you see my exponential rules, y1 a y2, and then this would equal to, well, we already know what this is. We just defined this. A to the y basically is, a to the y1 is y, and a to the other one is x. So we'll have y times x. So now we have this. So if we rewrite it, like if we write it together like this, y1 plus y2 equals y times x. So now if we do the log, or if we want to get what y1 plus y2 is, this one would just equal to log y times x. That's just basic definition. And if we look at this, this is the same. So basically log a to the y, log a to the x, which is this, equals y1 plus y2, and also y1 plus y2 equals log a y times x. So there's the proof. So now the fourth one, if we have log a basically y minus log a x, this just equals to log a, and this one's going to be y divided by x. This one is similar to this. Like this is a similar proof to this one. We just go up here, except for now we'll have a y1 minus y2, which will equal to basically a y1 divided by a y2. So that's all it is. It's divided by. If you see my other video on exponential functions, you'll see that, and then this would equal to basically y divided by x. And then you take the logs, it's going to be similar to this one. So you'll have y1 minus y2, and this equals to y1, this is y2. So that's the proof is similar to the top one. And now another really important one is actually if we have something like log a x to the r, r is any real number, this just equals to r times log a x. I'll show you the proof right here. Okay, so if we were to write, well, basically just look at our regular definition. We'll go x to the r equals to a to the y. So now what we could do here is, this is basically what this is saying. When this is what y is, so this one is y equals to. So what we could do here now is just go, both sides will go to the power of 1 over r. All we do is divide by r on both sides. We could do that because we're not changing anything. So this cancels. This would be left with x. This would equal to a y divided by r. And now we do the find the inverse or find the log. We'll get y over r equals to log a base a of x, and then just times r both sides, we'll get y equals r log a x. So this is same as this. So there's a proof there. So let's the last one we'll look at is, yeah, we're gonna look at let's call this 6 or whatever. This is the change of base formula. This one's really useful, especially when you're looking at natural logs. I'll show it later, and also with log base 10, which is mostly used. So if we look at, so this is the proof. Log a of x equals to log, this is basically log of anything, we'll call this b, of x over log b of a. Okay, so if we were to prove this, we'll just look at, again, when we go back to the definition, we'll get basically this one. We'll say y equals log a to the x, and this correlates again, it correlates to x equals to a to the y. Now if we take log b both sides, we'll go log b both sides. You could do this because these are both equal, so we'll just go with, we'll go log b of x equals to log b of a to the y. And then if we see if we scroll up to this one, the y just goes down because we know this proof, I proved that one. So then this would equal to y log b of a. So now we're left with, yeah, if we now then we're left with, yeah, so now we're left with log b of x equals to y log b of a, and then if we just rearrange this, we'll get y equals to, let's say, log b of x over log b of a. So there's the proof. That's it. So we proved this one. Well, that's enough for today. These are all the proofs. I'll just do some examples next time probably. So this is yeah, basically how logs are, the log properties, and this is, and you can see that these are all useful. You should keep these in mind. You memorize them because you will use them a lot. And this is basically the graph, how it looks like, just the inverse. You should also watch the other video on the inverse, on my other video, which is really useful to understand that all inverse is reflecting off the y equals x line. Well, thanks for watching, and stay tuned for another math easy solution.